Okay, the last part of systems we're going to talk about is linear inequalities. But before we talk about solving a system of linear inequalities, we have to learn how to graph a linear inequality. Okay, so a linear inequality is an inequality that has two variables. So it means I have a greater than or less than symbol, and I can actually graph this line on a graph. Okay, so instead of, remember, inequalities were like this. I had a number line, let's say x is greater than 3. I do parentheses, and I shade to the right, right? It looked like that. So I'm still going to be shading, but it's going to be on a graph. Okay, so I listed out all the steps for you guys. So it's going to be the same thing as if I had an equal sign. So I still want to put it in slope-intercept form, so I want y to be by itself. And then I'm going to graph that line using any method that you want. I recommend using slope-intercept form. And then I'll show you where to go from there. Okay, so when we have these inequality symbols, remember when we had just less than or greater than, we would use the parentheses, and then if we had the line underneath, so less than or equal to or greater than or equal to, we use the bracket. Some of you used open circle, closed circle. So those are going to mean something on our graph. So when you have less than or greater than, your graph is going to be a dotted line. So it's going to look like this. Okay, what that means, remember, if there's not a line underneath it, that means that anything on that line or on that number is not included in our solution. So that's kind of like our parentheses on the number line. It's going to be dashed because that's saying that any point on that line is not a solution to my equation, or sorry, my inequality. If I have a line underneath, it's going to be a solid line. So if you have a solid line underneath your inequality symbol, you're going to have a solid line on your graph, which means any point that is on that solid line is going to be included in my solutions. Okay, it's going to make that inequality true. Okay. I want you to note that there's infinite solutions for each linear inequality, just like regular inequalities that are graphed on a number line. Okay, that's why we shade the graph, because it's symbolizing all of the points that could possibly make this inequality true when I plug them in. So there's an infinite amount of points, x's and y's, that if I plug that in, will make that line, or sorry, that inequality true. So in number 1, my inequality is already in slope-intercept form. Okay, so I'm going to use slope-intercept form to graph this. Remember, this is my starting point on the y-axis. So I'm going to start at positive 4. Again, make sure you're doing it on the y-axis. A lot of us start on the x-axis, and it's going to mess up your whole line. Okay, then negative 6 over 5 is my slope. It could either be down 6 to the right 5, or it could be up 6 to the left 5. Okay, one of the directions has to be negative, not both. So I'm going to go down 6 so I stay on the graph. So down 6, that brings me to negative 2, and then I'm going to go to the right 5. Okay, and then I'm going to connect my 2 points. But I got to make sure I know what type of line I'm drawing. So since my inequality symbol, there's no line underneath, it's got to be a dashed line. So make sure you're extending your line all the way through. It's super important with linear inequalities because we're going to be shading where the solutions are. Okay, so to know where my solutions are, I'm going to pick a test point. Okay, so in our directions it says pick a test point that's not on the line. It's very important that you're picking a point that isn't on your line that you graphed. Okay, so if it's not going through the origin, I always like to pick the origin as my test point. So what I'm going to do is see, is this test point a solution to my inequality? Meaning, when I plug it in, does it make my inequality true? Okay, if it is a solution, that means that that test point is in the solution area. Okay, if it doesn't make it true, that means that the test point is not in the solution area. So I'm going to plug in that test point 0, 0 into this inequality. Remember, that's an x and a y. So I'm going to plug in that x and y and see, does it make this true? So 0 greater than negative 6/5 times 0 plus 4. So I'm going to calculate this out. So 0 plus 4, 0 is greater than 4. That is not true. Okay, so if you look at the directions, it says if the inequality is false, which ours is, shade the opposite line from the test point. So the test point is on this side of the line. Okay, well that ended up being false, which means I don't have any solutions on that side of the line, which means all of the solutions are on the opposite side of the line. So instead, I'm going to shade this area. Okay, that means the area that I shaded, I could pick any point from that area and I will have a solution to my inequality. So let's just pick a random one so you believe me. So I have, let's pick 5, 0. You don't have to do this. I'm just trying to prove to you that the area that I shaded contains all these solutions that'll make the inequality true. So I just pick 5, 0 from the shaded area. So 0 greater than negative 6/5 times 5 plus 4. So I get 0 is greater than, these cancel, negative 6 plus 4. So 0 is greater than negative 2. That is true. Okay, so this is a solution. Again, so you can pick any point from that shaded area, it'll make your inequality true. Okay, you don't have to do that, you don't have to check your answer, you're already checking by doing the test point. Okay, so in number 2, this one is not in slope-intercept form, so I have to solve for y. So I'm going to subtract over 3x. So I get 2y greater than or equal to negative 3x. Divide by 2. So I'm going to be graphing y greater than or equal to negative 3/2 x. Okay? So I don't see y-intercept. That means my starting point is the origin. And then I'm going to go down 3 to the right 2, counting my slope, right? Down 3 to the right 2. I want my line to extend all the way through, so I'm going to go the opposite way. So I could go up 3 to the left 2. Up 3 to the left 2. Now, before I draw my line and I connect my points, I got to see what type of line I'm drawing. Well, there's a line underneath my inequality, which means it is a solid line all the way through. Did I count this wrong? 1, 2, 3, 1, 2. Yes, I did. Hold on. There we go. Okay, so my line is actually going through the origin, so I have to just pick any other point. Okay, it does not matter which point you choose, just make sure it is not on your line. So it doesn't have to be the same point that I'm choosing right now. Okay, so I am going to go with 2, 0. Just cause. And I'm going to check and I'm going to see, does this make my inequality true? Is this a solution? So 0 greater than or equal to negative 3/2 times 2. So the 2's are going to cancel. I have 0 greater than or equal to negative 3. So 0 is always greater than any negative number. So this is true, which means this is a solution. 2, 0 is a solution. So that's saying my test point is in the solution area. So I'm going to shade on the same side as my test point. So everything on this side of the line is a solution to the inequality. Everything on this side right here is not a solution. Okay, number 3. Again, we have to solve for y. still on my highlighter. So I'm going to subtract 4x. So 5y is greater than negative 4x plus 5. Okay, then I'm going to divide everything by 5. So my inequality is going to be y is greater than negative 4/5 x plus 1. Make sure you're dividing your slope by 5. A lot of us forget to divide the slope, and then we don't have the correct slope when we're graphing. Okay, so this is the line I'm going to be graphing. So my starting point is positive 1 on the y-axis. My slope is negative 4/5. So I'm going to go up 4 to the left 5 to keep it negative. Or I could go down 4 to the right 5. Okay, I don't see a line underneath my inequality, which means this is a dashed line. Okay, and then I'm going to pick a test point. Well, it's not going through the origin, and 0, 0 is pretty easy to use. So I'm going to use 0, 0 as my test point. So I'm going to plug in x for 0, y for 0. So 0 is greater than negative 4/5 times 0 plus 1. Okay, well this is going to go away. That's just going to become 0, right? 0 times anything is 0. So 0 is greater than 1. That is false. So that means since the test point is underneath the line, I got to shade above the line. Okay, the opposite side of where the test point is, because that's where the solutions are located. So up here is my solution area. Okay, number 4. These are special graphs, remember. So x, anything without a y, is a vertical line. So I'm going to go to negative 2 on the x-axis, and this has a line underneath, so this is going to be a solid line through negative 2. And you don't actually have to pick a test point. You can if you want, but you could just kind of think about it. This is saying x is less than negative 2. So look at all of the numbers on the x-axis, right? And think to yourself, where are the numbers that are less than negative 2? Well, over here, right? All of those numbers that I just squiggled over are less than negative 2. So that means I'm going to shade this side of the line, because this is indicating all the numbers less than negative 2. Or you could choose your test point, let's say 0, 0. 0 less than negative 2. That's false. So you'd shade the opposite side of the line. Okay, and this one, remember y without an x, that's horizontal. So I'm going to put a point on 3 on the y-axis. There is no line underneath my inequality, so this has to be dashed. And this is saying all the numbers on the y-axis that are less than 3. Well, that's below the line, right? 2, 1, 1, negative 1. All of those are less than 3 on the y-axis, so this is where the solution area is. Okay, or again, you could pick your test point, let's say 0, 0, so 0 less than 3, that's true. So you're going to shade on the same side of the test point. Okay, I know in your notes you have u-tries, but I want to move on to actually solving the systems of inequalities, so don't worry about the u-tries, and go ahead and grab your system of inequality notes, and we're going to move into that. Okay, so solving a system of linear inequalities is actually very simple. If you understand how to graph a linear inequality, then this will be a piece of cake for you. So what you need to do is make sure both of your equations are solved for y, and then you're just going to graph them, okay? So I'm going to graph this first one in green. So I'm going to start at positive 3, and my slope is positive 6/1. Well, I don't want to go up 6 to the right one because I'm going to go way off the graph. So I'm going to go down 6 to the left 1, and there is a line underneath, so I'm going to draw a solid line. Make sure you are shading each line. Make sure you shade for this line first before you even go on to graph the second line. Okay, I'm going to teach you a shortcut. So if you don't like the test point, you can look at your symbol that's greater than. That means that all your solutions are greater than your line. So I'm going to shade above the line. Okay, well, above the line is above the slant. So I'm going to shade this area right here. Now, if you chose a test point, like say you chose 0, 0, that would end up being false. And you would end up shading on this side of the line as well. Okay, now I'm going to graph y is greater than -2. So starting point is -2. My slope is 1 over 1. So I'm going to go all the way through, down one to the left one, down one to the left one. So when we were just solving regular graphs, we would stop right here and be like, oh, there's our intersection point. Okay, but that's not what I'm looking for. So first of all, I need to create a dashed line. And I'm going to shade, choose a different color to shade for your second line. I'm just going to do blue. So y is greater than x minus 2. So greater than, that means I'm going to shade above the slant. So this whole area right here is the solution area for that line. Okay, notice that there is a large area that is overlapping between the shading, right? Do you see the overlapping? That is your solution area because that's the area of x's and y's that make both of these inequalities true. So what you're going to do is you're going to identify this area. So I usually like to just put an outline around it. So this area that I'm outlining right here is the solution area. You don't have to write solution area, but you do need to indicate that you know that the overlapping area is the solution area. So just outline it in a different color or what be it. Just make sure you're indicating you know overlapping of the shading is where your solutions are. Okay? Okay, and I'm going to keep using that shortcut for the shading because I think it's a lot easier than the test point. I just want you to be introduced to the test point because you're going to have to use that later on in other math classes. Okay, so in number 2, none of these are solved for y, so I got to solve both of these for y. So this one I get y is greater than -2x plus 3. And then I'm going to solve the second one for y. So I get 3y less than or equal to -x minus 6. And then you have to divide everything by 3. So I get y less than or equal to -1/3 x minus 2. Okay, so I'm going to graph the first line I'm going to graph is in light purple. So I'm going to start at -2. My slope is -1 over 3, so I'm going to go up 1 to the left 3. Or I could go down 1 to the right 3. Okay, there's a line underneath. So this is going to be a solid line. And my symbol is less than. So you shade below. Okay, you're going to shade below the line. So let's do the same color. So I'm going to shade down here. And then I'm going to graph my second line. So the starting point is +3. The slope is -2 over 1. So I'm going to go down 2 to the right 1. Down 2 to the right 1. Remember, I'm not looking for the point that they intersect. I'm looking for the shading that they intersect. Let me make sure I graph this right. So down 2 to the right 1. 2 to the right 1. Okay. Up 2 to the left 1. This one does not have a line underneath, so this is a dashed line. And then it is greater than, so I'm going to shade above the line. And I see that they're overlapping in this area down here. So this area is my solution area. Okay. Okay, part 2. So number 1, these are both already solved for y for me, so very easy. So hopefully you're noticing that these both have the same slope, right? So these are parallel lines. Before, when we had parallel lines with just solving a system by graphing, we would say automatically no solution, right? Okay, well this is different with inequalities because the shadings might actually end up overlapping. We don't know, so you actually have to graph these out to see. So I'm going to graph this first one in the green. So my starting point is -7 and my slope is 2/5. So I'm going to go up 2 to the right 5, up 2 to the right 5, or I could go down 2 to the left 5. Okay, and this is does not have a solid line, so I'm going to dash. I'm going to shade the solution area. It says that it is less than, so that means I shade underneath the line. And then I'm going to graph the second one in purple. So starting point +6, slope is 2/5. So up 2 to the right 5, up 2 to the right 5, or I could go down 2 to the left 5. And this one does have a line underneath, so I'm going to draw a solid line all the way through. And so this is less than. Okay, so that means I'm going to shade underneath the line. I'm going to pretend like that other line isn't there. Okay, do you see where they are overlapping? I hope so. Okay, so I'm going to indicate where that solution is. So even though these are parallel lines, these still have solutions. Okay, so what I just outlined right now is my solution area. Okay, number 2, I have another set of parallel lines. Let's see if these ones actually intersect and have a solution. So I'm going to do this first one in dark blue. So my starting point is -4, and my slope is -3/4. So I can go down 3 to the right 4, down 3 to the right 4, or I could go up 3, 1, 2, 3 to the left 4. 1, 2, 3 to the left 4. Okay. So that first one does not have a line underneath, so these are dashed. And it says that it is greater than, so I'm going to shade above the line. If you want to do the test point and you totally understand the test point, you can do that, but this is just a quick little shortcut. And then I'm going to graph the second one in pink. So my starting point is +3. And my slope again is -3/4. So I'm going to go down 3. Did I start 3? Yeah. So I'm going to go down 3 to the right 4. Down 3 to the right 4. Or I could go up 3 to the left 4. 1, 2, 3 to the left 4. Okay, and this one has a line underneath, so this is a solid line. Okay, and now I have to shade my solution area, so this is less than. So I'm going to shade below the pink line. Don't worry about the blue line yet. Okay, and I see that they are overlapping in between the two lines. So this right here is my solution area. Okay, again, so I have a set of parallel lines. They actually do end up intersecting. And I have a solution. Number 3, last one, I got to solve this for y first. So I get 2y less than or equal to negative 5x minus 8. Divide everything by 2. So y less than or equal to negative 5 halves x minus 4. Okay, so I'm going to graph these two lines. Again, they're going to be parallel. Let's see if they're actually going to have a solution. So I'm going to start at negative 4. So I'm graphing the one I just solved in blue. Okay, and then I'm going to go down 5 to the right 2. Or I could go up 5 to the left 2. Up 5 to the left 2. Okay, and this is a solid line. And I'm going to shade, let's see, it's less than, so I got to shade below. Okay, then I'm going to graph this line in pink. So starting at positive 5, I'm going to go down 5 to the right 2, down 5 to the right 2, or I could go up 5 to the left 2. Okay, so this one is a dashed line. And it is greater than, so I'm going to shade above this line. Okay, so in this case, the shadings are not overlapping. So we say no solution. Okay? And that's literally it for solving a system of linear inequalities. Now, when you're just graphing like regular inequalities, if you don't want to use the test point and you like just shading above or below, depending on the sign, you can totally do that, or you could practice using the test point. It's totally up to you. Let me just refresh your memory about that. So less than or equal to, you shade below the line. And then greater than or greater than equal to, you shade above. Okay, also, I want to make another side note. If you solve for y, and you divide by negative, hopefully you remember what happens when you divide an inequality by a negative. You have to flip the sign. Let me just give you a quick example. I'm not going to graph this or anything, but let's say I had like negative 2y greater than 3x plus 4. If I had to divide by negative 2 to get y by itself, you have to flip the sign. So it's going to become less than negative 3 halves x minus 2. Okay, so keep that in mind.